Okay, we're back, and uh, we're back with Mark Kapner, that energy guy, and he's drawn a graph for us to show us a little bit more in detail about how a bill works um, and some of the advantages of using solar energy compared to just using the grid. Uh, Go ahead, Mark.
Okay, what I've drawn here is called a load profile for a single day. Um, Load profile is a graph. The x-axis shown here is time, and it's commonly done starting at midnight, 12 midnight, 6 a.m., 12 noon, 6 p.m., and then the next midnight. So this is one day, a one-day load profile. The y-axis here is measured in kilowatts. Now, a kilowatt is a measure of the rate of energy usage. Kilowatt hour is a measure of the quantity over time. You could think of it very similarly to gallons per minute and gallons of water. Okay? A kilowatt hour is analogous to a quantity of electricity, analogous to a quantity of water, gallons. Kilowatt hour is a measure of the rate of usage, and the analog in water is the gallons per minute that a pump is pumping water, or that a user is using water. So it's a measure of the rate. Kilowatt's a measure of rate. So here we have a hypothetical load. It's called load profile. It's a profile of the rate of consumption of electricity measured over time. And it typically starts off in the middle of the night. People are asleep. There's not a whole lot of stuff on in the building. Maybe air conditioning is on, but it's operating at a lower level than it will in the afternoon. And generally, the load goes up and down as things are turned on and off, as your air conditioning works harder or less hard, lights turn on and off, computers. All that together creates a profile that's not a flat line, and it's gradually increasing in the summer, and it reaches its absolute maximum. Typically, most places it's around 6 p.m., sometime between 4 and 6. And then it gradually falls off and goes back down to the point where it'll start the next day. So for this day, the kilowatt peak is that number there, whatever this is on the graph. Now, the utility is measuring the kilowatts constantly, and they have a meter for every commercial building and every house of worship. In other words, every large building. There's a meter which tells the utility what the value of this kilowatt peak is, not just for a single day, but over the entire course of a month. It's called a demand meter. And they use that to measure the kilowatt peak of the month. And that's the number that is multiplied times the the dollars per kilowatt shown up there, which again is the sum of three numbers: electric delivery, demand, and regulatory. So those three numbers add together. In the summer, they add to $14.84. And that $14.84 is multiplied times the highest kilowatt demand shown on the utilities meter, which is measuring the absolute highest level for the entire month. So this kilowatt peak is the thing which the batteries reduce, and that's how you save money with batteries. Solar reduces the total kilowatt hours used, or actually you're selling those kilowatt hours to the utility at 11.7 cents a kilowatt hour. So that's how solar saves you money.
Okay. We are again in the discussion of how solar panels on churches, synagogues, and houses of worship can save money. And Mark, that energy guy, has shown us a bill, an example of a bill, and all the items on that bill, and is explaining to us the details of a bill and how things add up. When we come back, we're going to show again a copy of that bill, and Mr. Kapner is going to go over some more details. To subscribe, you want to click the button subscribe to learn more from Mark Kapner, that energy guy. Thank you and have a nice day.